Okay, geographers, the video prior to this, if you're watching this all in order, I got into linear scale. So we tend to just say scale, but what we're really talking about is some linear measurement here, right? Going from point A to point B. And that's all well and good if you need to go from point A to point B. But another key piece of this whole scale issue has to do with area, meaning something with more than just length, but width as well, right? And it typically, the easiest way to think about it, at least it's always been for me, is just to think about this in terms of things like real estate, property, parcels, things like that, right? We map that stuff out, whether we're doing actual cadastral mapping, which is the mapping of parcels for assessment purposes and all that, local government kind of stuff. But whether we're doing that or we're just, mapping where stuff is, we often want to think not just in terms of an address of some point of some place to get to, but in terms of what does this actual property look like, right? That's what we mean by area. So with this, a few different things here. I mean, just right off the bat, we can get into this idea of a graphic scale, much like the scale bars that I talked about in the previous lecture. We've got a similar thing on some maps, not every single map, but sometimes if you're lucky, you'll get something that looks like this. And so the way it works, the squares, you see that little tiny square with the 1 hovering over the upper right of it, that square that you're looking at would be 1 acre of land on the rest of the map, right? So you could figure out what that is. If it's 1 centimeter by 1 centimeter, there you can measure that out. You can figure stuff out. And then you also have 4 and 9 and 16 and 25. So it's just getting a little bigger, and that just helps you visualize how much land are we talking about. And it's quite useful. Let's see. I don't know if I said acres. It's square miles for this one. But you get the idea. Same kind of general idea, right? But this is useful if you're looking at, let's say, like for a lot of you guys listening to this, you're either doing the wildfire fighter stuff, fire tech stuff, or you're looking at some kind of field-based research. Either way, it can be quite useful to look at an area where you're supposed to be doing your work, whatever that work might be, but to get a sense, okay, how many square miles is this? How many acres is this that we're dealing with? So you can get a sense of how long is it going to take me to do whatever it is I need to do, right? To do this job that I've been giving, complete this task, and so on. So getting to think in terms of area, it's important for a lot of what you're going to do when you're using these maps, when you're actually trying to map stuff out, find things, that kind of stuff. But it's also kind of hard to do this because we don't always have these nice little graphic things on the map, right? Now, the good news is there are other ways we can think in terms of area, get a sense of what's going on here. And the best way to do this is through the Public Land Survey System, or PLSS. I'm going to explain what this is and how to use it, how to make sense of it, and I'll let you know, this is a more theoretical component right here. I'm going to get into the history behind it and the general concept, but I'm also going to put together a video showing a practical usage. So if any of this stuff as I'm going through, if it's not quite clicking, don't worry about it, because I'm going to show you how to actually locate these things, measure stuff with it, record this stuff, and all of that, right? How to actually use it on a map and in real life effectively. But what's great about this, it's two things. Number one, like we're talking about, it's a good way to get a sense of area and the actual size of an area on a map, and I'll get into that as we go on. But also, this is incredibly important to understand if you're going to do any work with land of any kind, and the mapping of land and finding of things and all of that anywhere in the United States. Like with the exception, I think I'll have a map in here in a bit. The exception of New England. Like if you want to go work in Massachusetts, this isn't going to be much help. But out here in the American West, this is really important to understand. And what's also ridiculous is that there's little taught about this. At least it was for me going through college. Nobody ever covered this stuff at all. And I remember getting to certain job interviews, and some of these job interviews they would slide a map, like a topographic map, across the table and ask me a bunch of questions on this stuff. And I remember specifically one of these interviews, and they asked about Township and Range, and I didn't know what the hell they were talking about, and that's a tad embarrassing in a job interview, and needless to say, I did not get that job. So that's another reason why I get into this stuff. It's important for a lot of you guys who are in this class because you want to work in this arena. Being able to read this stuff, being able to make sense of it, it'll help you out in the long run. All right, pep talk over. Let's get into what this thing is. So it's the Public Land Survey System, or we often just call it Township and Range. That's the other term that we tend to use. And so this was the idea of Thomas Jefferson, our third president, and Jefferson came up with this idea as a way to really get us, and I say us as Americans, moving west. And that's something that was always part of his plan. The idea that, and a bunch of the founding fathers, I think, that just the idea of the United States stretching from the East Coast over to the West Coast. Oh, that would be pretty slick, right? They wanted to go beyond these original 13 colonies. And so Jefferson, he came up with a plan to, as new lands get picked up, which I always, when you're talking about this stuff, it's always described in like the classic history books of, like purchasing the land or just acquiring the land. It turns out, I don't know if you guys are aware of this, there were some humans actually living in some of this area, doing just fine for a big chunk of the time, but they weren't using it right. That was really the attitude of early Americans here. It's bless their hearts, they're wasting this land, so we're going to take it. We're going to actually make it into something great, right? So that was part of it. It was part of what Jefferson was behind here, is how can we really utilize North America in the best possible way, and the way that God wants us to, and all that. So he comes up with this idea to, okay, when we get this land, right, however we wind up getting it, through purchase, through war, through whatever, we need to figure out a way to divide it rationally so we can populate it with Americans, right? Once you get this huge chunk of territory, you got to figure out a way to divide it up so you can sell off pieces of land to people, right? That's the idea. And what Jefferson, his whole deal, he's a fascinating guy because he clearly had this brilliant, logical mind, and at the same time, he was clearly an evil, awful human being. Slavery is the reason behind that evil, awful part. And people like to say, oh, but he loved his slaves. He had the one lady that he had kids with, or whatever. Yeah, that's actually called rape. You can't, by definition, you can't have a slave who you fall in love with, and it's all a beautiful thing. The slave part kind of ruins the love part. And there's actually evidence that is showing that he was, no matter how he felt about this one particular slave, he was cruel and allowed cruelty to take place to the other slaves that he owned. And there's a whole deal in history books about this. So not a good human being at all, but at the same time had this incredible scientific, mathematically minded mind, a big proponent of reason and enlightenment thinking. And whether you like the guy or not, he's responsible for a lot of why the United States is the way it is, right? Because he's there at the beginning. He's one of the founding fathers, and so this whole PLSS thing it's fascinating to think about and what it actually means. And the whole deal, here's another just crazy thing about the guy. The whole reason behind this PLSS thing, it was really to facilitate this kind of communist utopia that Jefferson envisioned. Now he's thinking of this about 70 years prior to Marxism and all that stuff. So I'm not saying he's a communist in that sense, but really what he's getting at, it's got that communist utopia ideal that we think of today, right? His whole idea was, hey, let's divide up the United States, what will become this bigger United States. Let's divide it up into just a bunch of small family farms. And on these farms, people they can just live their lives. They'll have everything they need, right, in terms of the means of production and all this other Marxist stuff, and they won't be able to be bossed around by some king, some government or whatever. They can just live the life they want in peace. Flaming commie. I mean, that is such a great thing. And what's also great is it's hypocritical for a variety of reasons. Like he's envisioning this equality, but of course it's only for white men. But also he was a guy who he loved to live beyond his means. He was always in debt. He tried to be flashy, like he wanted to be this elite guy, but at the same time he romantically thought about just he was but one of many of these small farmers who simple men living simple lives and all that. All right, but the reason, so when I get into this, just so you get a sense of why a place like California has been divided up in the way that it has been. Okay? It's all this legacy of Thomas Jefferson, all the result of his ideal having tiny little farms all over the place. Okay, and not just having that, but it's all very rational to get into it. It's a lot of squares within squares and grids and things like that, as you'll see. So it's a very logical thing, even though when you start to work with it, it can be a bit clunky. And I'll show that. So this map right here is showing the states that actively use the public land survey system. So the ones that are colored in use it. The ones that are left white do not. All right. Now clearly, you look over to the East Coast. You look to lands that were part of the original 13 colonies and all that. These lands on the east that are in white. Effectively, what happened was they were already divided up by the time this system got implemented. Right. So it's a very different feel. And if you've ever gone over to some of these cities on the East Coast, it can be confusing if you're a West Coast native. Like Boston baffles my mind. It's amazing how non-grid like that place is. I can more or less figure out a way around now that I have Google Maps and all that. But it's weird. Things just don't work in this neat, orderly, grid-like fashion that we have over here. So I'm always baffled when I go to the East Coast because stuff just doesn't feel right, because I'm used to being a California native. I'm used to this system, and again, you'll see how that works. And you might notice too, Texas is not colored in here. And I always like to ask students, like, why is that? And they have all sorts of great ideas about why it could be. They're always wrong because they say things like, well, because it was Spanish occupied. But that's ignoring the fact that everything from New Mexico to California was also this way. So that's not a valid reason. It's actually all it is. It's Texas just hates America. It's God bless them. It's just how those people are, where they don't want to be ruled by some kind of federal government, by Washington D.C. and all that. So they resist that kind of stuff. Bless their heart. So Texas is the one western state that doesn't do this. But you can see everybody else around here we use this system. And so if you look at it, you see these different lines in here. In fact, let me do some magic right here. I'll use this laser pointer. So we've got, like in California, we've got lines running this way to the north. And so with this, you can see north, I'll talk about this later on, but north is more or less at the top of the map. But these lines of longitude right here, those are what you follow to get to true north, right? But if you look at these, they're all at slightly different angles because of the projection of this map right here. All right, so if you follow them, you get to north, but you can see, I can't say that north is at the top of the map specifically because technically over here it's going at this angle, right? Like if I put a north arrow in the middle that was going straight up, that would be true for that specific area. But as that north arrow moves along, it's got to tilt with those lines of longitude, right? It's part of the fun, confusing stuff that comes with north. So I'm going to say, just generally speaking, these lines are running north-south right here, right? And then you've got some lines that are running, again, kind of generally speaking, east to west. Okay, so like this line right here. This is the Mount Diablo baseline. The baseline's that east to west one, and principal meridian, which is the north-south one right there. And then we also have a Humboldt meridian and baseline, and we have a San Bernardino baseline and meridian down here. And we have 3 of these origin points in California because we're a big, long, kind of funky state. Okay, that's the idea here. You can look into Nevada. They utilize our Mount Diablo baseline and meridian because it works once you get out there. It was easy to continue these lines to keep surveying this stuff out into Nevada. All right, and what the idea is all of these correspond with some kind of mountain or mountain range where you could get up to a high point and early surveyors could just look out to the north, to the south, to the east, and to the west in a very long distance and map out this stuff. And so this is the starting point for everything else I'm going to get into for mapping out these township and range grids and all of that stuff. So one thing that can be important as you work with this is to know what is that baseline and meridian you're using, right? Because if you are in, let's say you're doing something in California and you give me a township and range value, well, that's great, but I don't know. Are you talking about something that's connected to this Mount Diablo system here, or the Humboldt one here, or the San Bernardino one here? And this line, to kind of make things even more confusing for those of us down here in Southern California, this line, it runs through, it's somewhere in Kern County. I forget exactly where this happens. I'm pretty sure that's where it's like in the bottom of it. But these things meet up, and so it can be confusing if you're not, really clear with what your system is that you're using. For a lot of this stuff that we're going to be doing in this class, we don't need to worry about it too much, but I want you guys to be aware of that. All right, now from here, from this system of these different lines and all that, we have these squares that are built off of it. And so one thing I'll point out here is that the grid that we're talking about, it's like this right here, this simple reference grid from this book graphic right here, as opposed to this Cartesian system. Okay, so the Cartesian coordinate system, that's what we were doing with latitude and longitude. We were looking at where these different lines crossed, and so at those intersections, that was the location, the point that we would do on there, map out or whatever. This is the stuff you do in algebra classes when you start learning about XY axes and all of that stuff. And that's great for a coordinate system. And that stuff we'll do with UTM and other things down the road. With this township and range, it's important to remember that we're doing this stuff over here. And the important thing is that we're interested in the squares themselves. right? What's happening inside these grid squares, not what's happening at the actual intersections, right? So just keep that in mind whenever we're dealing with township and range. We're interested in area, right? And actual dimensions, length and width, not just some kind of point that we can draw on the map, but an actual area, an actual piece of land or whatever it might be. Okay, so just keep that in mind, and I'll be pointing that out as we go here. So, as I said, we have these baselines and meridians, those lines that we saw running throughout California and these other states. And so from here, from these lines, we have these 6 mile by 6 mile grid squares going in every direction. Okay, so they're going from the baseline, north and south of the baseline, and east and west from that principal meridian. And then within that, we have specific names. This is where that township and range idea comes from. The grid squares, as we count them up or down, so north or south from that baseline, we refer to those as townships, okay, as we go up. Or sometimes tier is a term that's also used. I use township because that's what I learned, and that's kind of the more standard one here. So the townships are counted north-south, and then as we count east or west from that meridian, we call that range. All right, and again, let's get to, I think I have an image here. Here we go, beautiful. So from here, you can see, we'll just look at this, right, to start with. We have that baseline running this way, principal meridian running right here. And so these squares, 6 miles by 6 miles, as we count up or down, we refer to that as a township. And as we count over, either east or west, we call that a range. And so this example right here, they've got this one written in, okay? It's 2 squares south of the baseline, so 1, 2. So it gets that T2S, township to south. So what you're going to do to actually locate any one of these individual townships here is you're going to start counting either north or south of that baseline. And so because this is 2 squares to the south, it gets that designation of T2S. And this is that other video that I have. I actually worked through this much more slowly and draw stuff out for you. So I'm just going to get through the general concept here, and then that other video will help you practice it and make sense of it, and hopefully it'll all stick. Okay, so T2S as we come down here. But here's the deal. All of these in this row, they're all going to be T2S, right? They're all 2 south of that baseline. So we also need this R value, right? So we count, in this case, because it's over here, we count west of the principal meridian. So 1, 2, 3 squares west. So not only is it T2S, but it's also R3W, meaning range 3 west. It is 3 squares west of that principal meridian. You dig? Hopefully you dig. And so this right here, this T2S, R3W, that's unique to this specific baseline and meridian. None of these other townships in here are going to have that value. Okay? But you can see that's why if you're working in a place like California where you have multiple baselines and meridians, this is where saying simply T2S R3 West, that could get you confused. Because we might say, well, are you talking San Bernardino? Are you talking Mount Diablo? Right? Maybe. That might be an issue. So you'd want to be more specific if you're kind of working in a big area. But the general idea is, okay, here's our specific township. We're not going to stop there, though, because this is the deal. This is why it's important to know what Jefferson was getting into here. That's 36 square miles. That's gigantic. There is no way you could have a single family farm all of that land and be able to successfully do it. That's a waste, right? So we're not stopping there. That's just kind of the starting point. So we have this township, and within it, the idea is we're going to divide that into 36 equal sections. All right, so what they've done with this image here is we've got this T2S, R3W, and then they show you down here, Township 2 South, Range 3 West. So they draw this right here bigger so they can fit in the 36 sections. Okay, so it's 36. This is rational. This is Tom Jefferson stuff. So they're 1 square mile each, right? To maintain this proper size and rationality and all that. And of course, we're fitting squares, just trying to impose order on the landscape, even if it doesn't make sense. And you'll see that with some of these maps where the squares don't always work out. But by God, a guy like Jefferson is, let's put rational squares on this chaotic wilderness that we're conquering. Right? That was the idea. So we've got these 36 sections here. One is always in the upper right or the northeast corner. It always starts right here. And it counts over 2, 3, 4, 5, 6, 7, drops down here, goes over to 12, 13 drops here, goes over to 18, and so on. So it just snakes back and forth, with 36 being down in the southeast or the lower right corner. Okay? This is important to commit to memory, and you'll see, like with the other video put together, as you watch that, you'll see why it is important to remember that, because you're never going to see a map of a township. I should say you rarely see something like this, where everything is perfectly fit in here, everything's labeled, and all of that. No, usually you got to have this knowledge to be able to make sense of what you're actually seeing on the map in question, right? To be able to use it. So just remember this, commit this to memory. 1 is always in this northeast corner. And it's important to remember too that it's specifically 1's up here, 6 comes over here, and then it does this back and forth thing, right? So the way in which these things are numbered, are labeled here. Because if you don't do that, let's say you do 1 to 6, you remember that, but then sometimes people start over, okay, so 7 to 12 over here, and then 13 to 18, 19 to 24, you do it that way, you're going to get the wrong answer. It's going to screw up these sections, and you're not going to actually know where you need to be looking or where you need to be going or what the actual location of this thing is. So again, commit that to memory right there. Okay? So we've got these 1 square mile sections that are equivalent to 640 acres. And I say this whole, 1 square mile and 640 in terms of acres here, that's good to remember because this gets back to our whole area idea. If you're looking at a map and you're looking at a section, you know that's equivalent to 1 square mile. You know that's equivalent to 640 acres. And the map we'll be initially practicing this with is the Lancaster West topographic map, that one I had you guys download. That you'll see, it's actually kind of nice to keep this in mind, to know this. It helps you get a sense of the size of things because these sections are so clear in a place like Lancaster and on a map like the one that we're going to be using, right? So I point that out, and you should also commit that to memory, the size of these sections. But then here's the other thing. In fact, let me see. Do I get into here? Yeah. You'll notice as I show this, we've got this extra stuff right here, right? What's going on with section 14 here? This is what's called aliquot subdivision. And so aliquot simply means we're dividing these sections into equal pieces, okay? It's just a fancy word. It's kind of like Jefferson. This is where this stuff comes from. So instead of making sections within the sections or whatever, once you get to the section level, to further divide that, because of course we want to do that, 1 square mile, 640 acres, that's gigantic. That's way too much to be just, for one family, their farmland and all that. No, that's not going to work. So we divide each section into quarters, right? We divide it into 4 equal pieces. But then what's really crazy is we can continue to divide this stuff into 4 equal pieces here. So we get a quarter of a quarter, and then a quarter of a quarter of a quarter, and so on, and it just keeps going, and you get to play with it. It's fantastic how the system works. One thing you sometimes see is a lot, right, which just refers to this area in a section that just it can't evenly be divided into a square for whatever reason, for whatever natural feature is there. Sometimes we have a body of water, or if it's at a coastline or something like that. Sometimes it's simply referred to as a lot. Or sometimes what we'll also do is we'll just divide, instead of doing it into a quarter, sometimes we divide things into halves. Let's see, I think, yes, right here. So here's that same image we're looking at, but bigger. So let's look back here. This is section 14 of Township 2 South, Range 3 West, and then we can continue to divide it. So the initial aliquot division is right here in the middle, right? So we get it into these even quarters. So you've got this northeast quarter right there. This would be the northwest quarter, southwest quarter, southeast quarter, right? Simple enough. But as I said, we can continue to divide it. So just looking at this one right here. So this is the northwest quarter, this whole thing, but it's been further divided into quarters right there. So this shaded one is the one we're supposed to be looking at. This would be the northeast quarter of the northwest quarter of section 14 of Township 2 South, Range 3 West. Right? That makes perfect sense. That is logical. And of course, the first time you look at this, you might go, the hell? It might not sound logical. It might be very confusing. But really, once you get working with it, it makes perfect sense. It's easy to work with here, right? So trust me on this. And again, that other video, I'm going to get into how this works. I'll go slowly through it and actually show how to work through it without all the answers right here. So I'll get into that if it's confusing. But just as I continue here, two more things to point out. We've got some of these halves, as I said, right here. So with that, instead of saying, northeast, northwest, that kind of stuff, it's simply the east or the west, north, south, or whatever. So like this, I think we've got it written out right here. So this area is its address, its location. It's the west half of the southeast quarter of section 14 of Township 2 South, Range 3 West, right? This would be the north half, the southwest quarter of section 14, da 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 da. And then you can see here these lots where you've got a lake coming in here, and it's effectively saying you're not getting a perfect quarter of land, so it's just described in that way. So if you ever see this description and it says lot 2 of this quarter of this section of township or whatever, that's what's going on right there. Does that make sense? Thank you, Tom Jefferson. This is fantastic. This makes perfect sense. Trust me, it will. You'll get there. And so one thing too, as you're starting to, locate this stuff. Let's say that I give you, a map, and I ask you to tell me, okay, what is this location in terms of township and range in this PLSS, system here? What's going on here? What you want to do is start with the most specific or the smallest area, and then work outward. Okay, so it's the idea that we have, like with this one here, this same example we've been using. What you're starting with is this northeast quarter. So you ignore all of this stuff over here, and you're simply looking. Let me do some more awesome technology stuff. I think this will work. So beautiful. The first thing you do, that looked rough, right here, is just within that little red square that I drew, you're just going to look in there, right? And so the northeast quarter, out of all of this stuff, we're just looking at this guy right there. So yeah, that's in the northeast, right? Because that's north, that's east, This is where that never ever smoke weed stuff comes in handy, right? So I know, okay, haha, northeast, right? That's where I'm at. Then once I've located that, right, and so we write down northeast quarter. And then I'm going to look at all of this there in relation to, do this on a trackpad, that's why it's so beautiful, to the rest of it, right? So now, if we're looking at this stuff, in fact, come on, technology, there we go. Eraser, yeah. Let's get rid of this so it's not confusing. So now if we're thinking north is over here, east is here, that means this is west over there. So now we know, okay, this in relation to everything else, it's the northwest quarter, right? That's what we're looking at right here. So the northeast quarter of the northwest quarter, then we're going specific and expanding. So then we say, okay, of section 14, of Township 2 South, Range 3 West, and of course, being a good geographer, I put the San Bernardino baseline and Meridian, even though that's not necessarily what this is, but if we're doing this properly, we're always going to include that with what we're working on. It's a good habit to get into. All right, so that's how this works, and so I'm pointing this out because if you swap these, right, if you don't work from the most specific outward, and some of these I'll let you know, you get into 4 or 5 of these, this quarter of this quarter of this quarter of this quarter. If you swap any of those, you're going to screw your stuff up. You're going to get a wrong answer, right? So that's why I'm stressing this right now. Be aware of that stuff. Hopefully that makes sense. Again, I got the other video. You're going to have practice with this. It's going to be glorious. All right, so there's that. Okay, this is effectively what I'm showing you in the other video. I mean, you can test yourself with this if you want to pause this right here. Just this idea, kind of like what we saw earlier, A and B, these are specific townships, so they're going to have that T and that R value. This over here is simply this township, but drawn over here. So D and C, not only does it have a township and range value, right, based on this square right there, but it's got a specific section. Like D, what's that section? That should be obvious, right? That's clearly section 1 of township something, range something, right? This section right here, if we look at that has that aliquot subdivision. So you could look at this and you could, specifically say what's F, what's I, E, that kind of stuff, and describe that. It's this quarter of that quarter of this section, of this township, of this range, right? That's the idea. Feel free to play along with this, but I'm going to give you, other things like this to play with. And then again, that other video, get into the actual practical stuff. Okay? Now, as you're working with this, it's good to note that these early surveyors were not perfect robots going out into the world and putting these perfect squares onto the land. We have all sorts of irregularities, and you're going to see that working with different topographic maps of California just alone. You'll see this where you have, some of these squares will be perfect, and then you get up into the mountains and they're more trapezoids and they get funky, definitely funky, and that has to do with a handful of things. The instruments that were used, the fact that in some cases they'd send surveyors starting from this side and others would come from this side, and where they meet, it didn't perfectly line up for whatever reason, and so stuff gets squished. There are other things. There are stories of some of these guys, like the way the government did this is they'd pay a survey crew, however much money for however many months of work or whatever you do it, and a lot of that money apparently would get spent on whiskey. And it was like a sweet camping trip. And then they go, oh God, we got to get something to the government, and they'd quickly map out this stuff, and it was garbage because they were all drunk and or hungover, and America, there you go. That's how we roll. So that's while you'll see, even though it's supposed to be all perfect squares, it's not always perfect. And so that gets back to this idea of area, and locating this stuff, remember that when you look at this, if you see a perfect square, if it's clear, especially in a flat area like the floor of the Antelope Valley, yes, those sections are 640 acres, 1 square mile. Oh, beautiful. But you start to head out into the mountains. No, you can't assume that it's that proper size, those proper dimensions. Again, because of drunk cowboys. That's the idea. But getting back to like why this is important, not just for you because you might have a job interview and have to be able to read this stuff, but just looking at the United States and specifically like the Western United States, you can see this is still there, right? All these years later, after the Jefferson presidency and his implementation of this stuff, it's still out there. If you ever fly anywhere around the American West, and you look out the window, like invariably somebody is going to say, hey, look at all them squares, right? That always happens on a flight. I love it because I get to talk about, hey, you want to know why you see those squares? Nobody ever wants to know why, but yeah, it's I can't help myself. But yeah, when you look down at that, you see that's Thomas Jefferson. That's the public land survey system. That's what we're dealing with, and it's this aliquot subdivision. Right now, since then, we've had, of course, this farmland has been bought up. It's been turned into suburban housing. So everything started out this way. We had these nice squares and rectangles and all of that throughout a place like, say the Antelope Valley. It was all lined up in this way. But then, developers come in and they try to erase the squares. They put in as many, houses as they possibly can, and they curve the roads and things to try to make it feel more European and old worldy and all that. But that's still that stuff. It's been squished into this whole township and range system. So it's everywhere, and it's there's some fascinating ideas in geography about like what does this mean for voting patterns and stuff like that. Where in areas where you still have this public land survey system, you see more conservative voting because you've got folks who don't really have, the nearest neighbor is like a mile away on another one of these sections, and so therefore you're trying to, you do things by yourself. You've got that conservative mindset, whereas people who aren't living in this system as it exists here, they vote more, for the Democrats because they're more about being in a community living together. The East Coast has these different settlement patterns and so on. Now, whether that's true or just, crap, that's for another discussion, another time. But it's still, there's a lot going on with just this simple grid system that's been put in place. All right, so hopefully that makes sense. Also, I should warn you, if you get to France, or not France, it's to Louisiana, which used to be part of France, now we got it. Some of the stuff is just, it's crazy, because the French, crazy. Their whole idea, they didn't do squares like good, rational human beings. They did long rectangles. And the idea was like you get your long rectangle in here, and I'm sure a lot of it has to do with, the crazy rivers that are running through a place like Louisiana here. But you get these long lots right here. And then the idea is like, I would get this, start out, and then when my son comes of age, I'd like cut it in half or whatever. And he'd get the back lot and I'd keep the front lot or something like that. That was the idea. You just keep kind of dividing it, and then I'd eventually die, and then my grandchildren would take over my lot, or I don't know, something. I don't know. I'm not French. I don't know, but that's the idea. So if you are doing any work in Louisiana, just be aware things are going to get extra wacky because of that French influence that's been preserved, right? That's been maintained. Okay, that's enough for that stuff. This whole detail, the rest of this lecture, I'll put that in another video so it's a little more manageable here for you. But that's the public land survey system. Think about that stuff. Practice it with the other video and the stuff you're going to be doing in class, the activities that I'm going to provide for you guys. And by the end of this class, expect you guys to be pros at using it so that when you do go for that job or when you need to work with it in the job that you somehow got anyway, I want to make sure that you guys, this, you're good at this stuff because it's it's incredibly useful to know. All right, that's it for now, geographers. Have fun playing with your townships.